Hello again. We're going to talk today about solving advanced quadratic equations. Your homework's going to be from Chapter 1, Section 5. Here are the recommended practice, and then 22 is the presentation problem. Make sure before you get started with the video that you've got your note-taking supplies out and ready. So, number 1, solve w squared plus 5w equals 6. Now, if you remember from previous years, the way to solve quadratics like this is to start by setting everything equal to 0 and then try to factor. So we start by setting it equal to 0 here. We're going to subtract 6 from both sides, and we'll end up with w squared plus 5w minus 6, since there's no like terms, equals 0. So now we've done that first step. We've got a 0 on one side, and we've got our quadratic on the other, and we try to factor them. We want to multiply to negative 6, add to 5, which would be w plus 6 times w minus 1 equals 0. Now, as you might remember, not everything is going to factor. If it's prime, so prime means it can't be factored, that means you're going to want to use the quadratic formula, which states that if our equation is ax squared plus bx plus c equals 0, then x is equal to, and I'm going to pause here, negative b plus or minus the square root of b squared minus 4ac all over 2a. And you can use the quadratic formula for any quadratic problem, but I will warn is that factoring is going to be a lot easier, and most of these are just going to let you factor them. So here we have two things that multiply to 0, which means in our solution that w plus 6 equals 0 or w minus 1 equals 0. And most of you have just been trained to say, okay, well, w plus 6, if that equals 0, w is negative 6. W minus 1 is 0, that means w can be 1. And we've got our two solutions to our quadratic. This is a pretty straightforward quadratic. It's got the negative, but that's about it. Now, let's look at a few more tricky examples. Here, we have 3 over 2 minus 2 plus x over x squared equals 1 over 4x. Now here, we see we've got a quadratic, but we also have fractions that are being added and subtracted. So just like we talked about in the first video this week, we are going to find a common denominator, which I'll often shorten just to common denom in the notes. So whenever we're adding or subtracting fractions. Now here we've got the denominator 2x squared and 4x. So the common denominator across the board will be 4x squared. Now for the first term, we have 2 in the denominator, so we need to multiply by another 2 and the x squared on both sides. So 2x squared. Here, for the second fraction, we want 4x squared. We have the x squared, so we're going to multiply that by 4. And at the last one, we'll just multiply by x. So then our numerator for the first term is 3 times 2x squared. So we end up with 6x squared minus 2 plus x times 4. You're going to make sure that you distribute that. So that'll be 8 plus 4x equals, and now it's just 1 times x on the last term, so x. The point of putting in a common denominator here is then when we multiply both sides of our equation by that common denominator, whoop, dropped the squared there, so sorry, by 4x squared, which we can do since we're doing the same thing to both sides, the denominator cancels out for all terms, and we're left with just a nice equation, 6x squared minus 8 plus 4x, which you can write like this, or if you ever see a fraction with the term in front of it like that, make sure you're distributing. So you can also have it as, in this case, minus 8 minus 4x equals x. Now it's a regular quadratic like you're used to. Subtract x on both sides to set it equal to 0. And I'm going to do a little reordering here. I'm going to keep my 6x squared in front, and then negative 4x minus another x minus 5x minus 8 equals 0. Now we'll ask ourselves if we factor, and in this case it's actually going to end up being prime, and so since it's prime, we will use our quadratic formula. Now if you remember, the quadratic formula always starts with ax squared plus bx plus c. So that means that 6 is our a, negative 5 is b, negative 8 is c. So that when we plug it in, our solution is x is going to equal negative b, so negative negative 5 is 5, plus or minus 5 squared, which is 25, minus 4 times a, which is 6, times c, which is negative 8, all over 2a, just 2 times 6. And if we just take out our calculator, we can work that down to 5 plus or minus the square root of 217 over 12. 217, I do not believe simplifies as a radical, but since we haven't gone over that fully yet in class, I won't expect you to simplify those just yet. Now, it's always important when we have denominators with variables to make sure we're checking for extraneous solutions. And extraneous solutions are answers that work at the end of the problem but don't work at the beginning. So in this case, the only extraneous solutions here would be 0, since that would make the denominator 0. Neither of these answers are 0, but it's always important to look for those. Our last example, you'll notice this isn't quadratic, but you'll see squares, and often what works for squares, for square roots and squares, are similar. So we have fractions here, and we're going to start again by finding a common denominator, which in this case we've got 9 and root 27, which I am going to say, oh, well, root 9 is already root 81. And I happen to know that 27 only needs to be multiplied by 3 to be 81. So if I multiply over here by root 3, and of course the same thing on both sides of the fraction, I am going to end up with the common denominator of root 81 here as well. So that's exactly what I'm going to do. And for the last one, if we've got a term without a denominator, of course it's over 1, and I'll just multiply both by 9 to have that common denominator. So here we have common denominator of root 81. We're going to cancel them all out here. Since it's the common denominator, make sure that we've got our subtraction sign going to both parts of that fraction, and we end up with x root 3 minus x minus root 3 is equal to 9 root 12. Now what we want to do next is we have x terms, but we can't combine them because one has a root and one doesn't. So what I'm going to do is I am going to add the root 3 to both sides, and then I'm going to simplify and factor. So here we have our added root 3 on the right, and I factored an x, leaving behind a a root 3 minus 1. Now, here's where we're going to review simplifying roots a little bit. If we have root 12, that's the same as root 4, which does exist, and root 3, which is irrational, times 9 here. So we can rewrite that as 9 times root 4, which is 2. Then we still have the root 3, which would simplify 9 times 2 is 18. Root 3 plus root 3 from above. And now the left-hand side here, x equals root 3 minus 1. I'm going to write it up here. X times root 3 minus 1 is now equal to 18 root 3 plus another root 3, which is 19 root 3. Divide so that I can get x by itself. Root 3 minus 1 on both sides. And we're left with x is equal to 19 root 3 over root 3 minus 1. Now we can't leave a root in the denominator here, so I'm going to erase some of this to make up some space. Obviously, do not erase from your notes. So now in your notes you have all this solving that got us down to x equals 19 root 3 over root 3 minus 1. To get rid of that root 3 minus 1 in the denominator, we multiply it by its conjugate, which is root 3 plus 1. Root 3 plus 1. If this isn't something that you're familiar with from previous years, I really encourage you to grab one of those appointment slots so that we can talk about simplifying square roots. So the nice thing that happens here is that if you then expand the denominator using the FOIL method with the conjugate, is you get root 3 times root 3, which is 3, and then plus root 3 minus root 3 for the outer and the inner, which cancel out, and then negative 1 times 1, which is just minus 1 in our denominator, so we've gotten rid of the root. And then when we distribute the numerator, we end up with 19 times 3, because again, root 3 times root 3 is just 3 by itself, plus 19 root 3 from being multiplied with the 1, and we'll simplify from there. We end up with 19 times 3, which is 57, plus 19 root 3 all over 3 minus 1, which is 2, as our final answer with a rational denominator. I know this video is a little bit longer. Please ask me any questions in the comments or grab an appointment slot. I'll talk to you later. Have a wonderful day.